Hi, I'm Chris Gamble, and I run the Supply Frame Hardware blog. And today we're talking to Thomas. Hey, Thomas, how you doing?
Hi, Chris. Doing pretty good.
Thanks for being here. So, Thomas has given a talk at a past hardware developer Didactic Galactic, which is our meetup in San Francisco. And today we wanted to talk about something we're calling a DfM case study. This is based on a device that Thomas has built. It's an open source device. Can you tell us a little bit about it? And while you do that, I'm going to switch over to the talk page where you had shown it before.
Yeah. So the name of the project is KBox. Signal K in the marine world means I want to communicate. It's usually a yellow flag, and so KBox is a gateway that connects the networks that are available on the boat. So mainly a CAN bus and a few serial bus to Wi-Fi, so that from your iPad you have access to all the instruments that are installed on your boat.
That's great. And so this doesn't exist. Why doesn't this exist in the world already? Or
Well, actually,
does it at a higher price?
yeah, it does already exist, but it's a pretty high price. The marine industry uses a bunch of proprietary protocols, and recently people have reverse engineered those protocols and started making software for it for the Raspberry Pi or for Arduino, but mostly based on proprietary hardware for the gateway to the actual network. So the idea with KBox was to enable the sailor software engineer open source hackers to have access to their boat in a completely open source way, including the electronics that connect them to the boat.
That's great. Okay, cool. And so it's got all of these different things. So like you talked about, here's all the different things you were talking about, all the different uh, devices that can go along with it. What are some of the challenges that are associated with building a piece of hardware like this?
So my idea initially was that I'm gonna use a teensy microcontroller. I'm gonna use a little screen. I'm gonna use a ESP8266 Wi-Fi module. And I made a little back of the napkin calculation. I was like, oh, this is gonna cost me like $50. I can sell it for $99. It's gonna be awesome. And the reality is that today, and I'll share the exact numbers with you guys if you're interested, but the actual cost of manufacturing of one board is more around $180,
Well,
and that includes the enclosure, assembly, all of that. But if I want to make the product available to more people, and I have to cover for some overage and some of the boards just don't work, like right now I'm selling it for 279, and I don't think I'm stealing anyone at that price.
right,
And
right.
I'd like
You're not
to,
gonna become the next Apple doing that, right?
yeah, exactly. And I'd like to be able to sell it at a much lower price actually, so that more people can have access to it, or sell it at this price, but with a lot more features.
Right. And this is
And
something
so
we talk about on the blog a lot too. Of you're basically at the point of prototype, proof of concept, that kind of thing. You're now taking it into production, right? You've proven out that some people want it. You've basically you need to scale in order to get those costs down. And so you mentioned you've done some assembly already. Can you tell us a little bit about what you've done to get the first boards assembled?
Yeah, so I started assembling them myself with my reflow oven and placing the parts, and I quickly realized this was not going to work. There are over 100 parts on the board. So I looked for a manufacturing solution, and the one I'm using right now, I've used PCB-NG in the past. Now I'm using Macrofab. They're both great services. Macrofab goes a little further in the assembly, so they'll do drilling holes in my enclosure, mounting the board, mounting the LCD panel on top of the board. So right now I'm using them because they do almost everything. I get the K box, the product, in a little plastic bag, completely ready.
Right. And you
And
mentioned
so
that you have some docs you can maybe share about that.
yeah, absolutely. So I can show you first. I don't know if people are familiar with. Can you see my screen?
I can. Yeah. Let's get that up there.
Sorry, I'm gonna re-log in. But yeah, so this is what microfab interface looks like. And so when you create a project here, I've declared my Keybox V1F projects. I've had different revision of the hardware, and I've already uploaded and spent a lot of time in the UI working on this one. So the project here is completed. So you can see this is what the PCB looks like, and then all the placement will come in the last step where you're actually confirming where each part go on the board
Right.
and getting
They keep their costs down by actually pushing off some of the verification of assembly to the user, correct?
yeah, which is totally fine with me because I think that's totally my responsibility as a designer.
Hmm.
But getting that to work well with KiCad and be completely automated, I think should be almost the subject of another video. But
Okay.
I have that process working pretty well now, and so if I do a new revision, it takes me still, a few hours because you have so many things you want to check many times.
Hmm.
But in general, that's working pretty well now. And so the part that I think is interesting then is the bill of materials. So they will, those are all the parts that they will buy for me. So you can see all the ones that are marked Populate and Sources Market. They will go and buy those for me.
Hmm.
And actually, this one here, for example, the WS2812 RGB is a component that you don't find on DigiKey yet. I actually have no idea why, but the ESP8266, the WS2812 RGB, and the ILI 9341 controller-based TFT screens, those are parts that you don't find on DigiKey or on Mazur. So what I do is I buy them on AliExpress. And then I tell them, so if I was to do a new order, I would tell them to consign those parts. And so the parts cost is going to show at zero because I mail those parts to them. Uh,
Gotcha. And so that's actually an interesting point about all this stuff is you're using parts that are very popular in the the prototyping ecosystem, like the WS2812, which is a serial controllable LED. And so that's something I think about where. So when you're really talking about DFM, it's also about kind of almost redesigning certain parts of your design, right? So that might turn into maybe it's no longer a serial control thing, maybe it's an actual tricolor LED. And similarly, maybe it's no longer I mean, obviously it's a much bigger deal for the Wi-Fi piece, but maybe it's no longer a finished Wi-Fi thing like the ESP8266, but now maybe it's a Wi-Fi module where you're talking to it over a different command set, but you've proven out that the Wi-Fi is important, right? So just kind of all those
yeah,
trade-offs.
yeah. And so in the case of the WS2812, I completely agree with you that I should probably replace that with a I2C RGB controller and then a few RGB LEDs.
Hmm.
If I really wanted to keep it, but I think what's going to end up is that I'm going to remove this feature because it looked great on the prototype, but
Right.
now that I have a screen, so I have to kind of consider whether I really need RGB LEDs in addition to a screen.
Right, and these are the trade-offs that happen in any DFM process, right? It's obviously you've proven out the thing. Now you're talking about, okay, so now how do we actually get the cost down? How do we make sure it's sourceable? How do we make sure that everything about this device makes sense for, well, I guess I don't even know. How many do you think you'll need to make eventually? That's obviously another big piece.
Yeah, so far I've sold or I've made 23 boards. I think there are a few that were defective or that have a problem, so I'm using them as development board, or I'm using one on my boat that has a defect. But I've probably distributed to people around me or sold about 18 or 19 boards, something
Okay.
like that.
Yeah, that's great.
Um, and I'm selling on Tindy. Last time I put new boards on Tindy, they sold out in 3 hours. And so
That's a
I
bad
just
problem to have
ordered.
there, man.
Yeah, yeah, no, I know, but it takes me so much time to get more up there.
Yeah.
And so right now I've placed a new order for 10 more. I'm placing a new order for 10 more with
Right.
microfab. So
Right, and that's another thing to mention actually is so obviously you're bootstrapping in here, so each sale basically funds the next round of purchase as well. That would be different than if you took on funding. Not saying that you're actually not making this like a full time thing either, right? Obviously you have a job,
yeah,
but
yeah, it's totally a side project.
right, and so that would also change the equation of okay, if you had a chunk of money, now you could go and build a pilot run of 500 units, 200 units, whatever it is. That
Yes.
does change a lot of about what you're doing here.
Yes, but I do love the idea of bootstrapping it and getting more opportunities to iterate on the product and make it better.
Yeah.
So that's something that I've been enjoying a lot, and
Right.
and I like the challenge of trying to do it this way. But it does make the DFM even harder.
Well, I think that there's certain points where it actually is better, right? Because you can make a Rev 2. Well, you already said you're on V1F, but you can make a Rev 2 that's significantly different from an architecture standpoint, right? But then you could still push that out. Your customers are still willing to try out new things, and I think that's actually a really powerful
Yeah.
thing. So
Yes, it is very powerful, but then the software guy in me has to stop you there, the EE guy, and to say, hey guys, if you change the hardware on me on every iteration, we'll
right,
never make any progress on the software.
that's
And on
that's
a
a great point. Yeah.
product like this one, the software is a huge part of the design investment. I've spent a lot of time on the hardware, but now over I've been working on this project for something like 2 years. I've spent probably as much time, if not more, on the software now, and
Hmm.
there's still so much more to do on the software.
Right.
And so I've had lots of ideas for V2 that would reduce the BOM, make it easier to manufacture, but I've refrained myself from working on it yet because I want to get the software to a better place first
Hmm.
before I go back and reiterate on the hardware and rejig everything. And as much as I'm willing to ditch the RGB LEDs because they're not that useful, the Wi-Fi module, for example, is a critical piece of the architecture. And if I switch to another type of Wi-Fi module, that would be a big
Right.
investment in software. And since I'm working on pretty small quantities, I have to consider whether the software cost, the weeks I'm going to spend rebuilding something on a different architecture, are actually going to be worth the reduction in BOM. So that's also
Right.
something that I've been trying to keep in mind.
Right. Well, and so we should mention that you are a firmware slash software developer full time, and so you actually have seen this from the other side, right? You've seen the effects of, like you said, there's huge trade offs in using lower cost hardware. The thing we always talk about is cost, quality, and speed. Pick two, right? And in this case,
Yeah.
you've foregone the speed piece in order to get a relatively low cost, maybe not lowest cost, but a higher quality thing. And now if you want to speed it up, if you want to get higher quality, you either need to pay a lot more, or if you want a lower cost and you want to speed it up, you gotta drop your quality, right? So it's always those trade offs.
Yeah, yeah, yeah. No, it's always a trade-off. Yeah, for sure.
Well, we should also mention here that if people are watching and you are a software engineer, firmware engineer, Thomas is looking for assistance, as always, with any hardware, open hardware project. The people like doing the hardware piece, but the software is
Yeah,
what
yeah,
makes it.
exactly. The idea, if you're selling and you're interested in selling hardware, the entire idea of manufacturing this and going to find microfab and making more than one board just for me is so that other people can come help me on the software
Yeah.
pieces. So you can go on Tindy, you can get the board, everything is open source, the software is completely open source, and then you can actually contribute to the project. So yeah, if you have a Raspberry Pi on your boat, I need your help.
That's right. So let's. Can you talk me through a little bit more of the costs? I remember you had like a spreadsheet
Yes,
about other
yes,
costs here.
absolutely. So this is just an overview of the costs. So can you see that well?
I think so. We'll have to see how
Yeah.
it turns out. If not, we'll definitely share a link, or we'll have an overlay for the screen.
Yeah. So this is what this batch that I'm working on 10 KBox is going to cost me roughly. So if we walk through the line quickly, at the top here you have a few parts, 3 parts that I have to buy and consign with Microfab.
Uh huh.
So they're the TeamZ bootloader, which is a special part that I buy from pgrc.com, Paul Stoffrigan,
Mm-hmm.
which enables the microcontroller to be programmable on the fly via USB without, it just simplifies the development process and makes this a little bit more friendly. So that's a $7.7 cost per piece. And the way I calculate that is I actually look, those are all the orders I got from my suppliers. And so you can see that the bootloader, for example, I've reordered 20 of them this week. And I'm including the shipping cost and everything. So I don't know if that's how people normally do that, but I haven't found a good way to deal with shipping and accounting. So I just recalculate the unit price every time.
Right. No, I think that is definitely baked into the cost of the overall cost. It's definitely something to
Yeah.
take into account, because larger quantities would obviously have be shipping. The shipping gets amortized over the entire amount of things you're buying.
Yeah, and when you're buying from different suppliers like that, like shipping definitely adds up.
Hmm.
Especially if you're trying to rush thing and paying $20 shipping every time. I don't do that anymore, but that was a big mistake I did in the beginning.
Right, but that's actually another DFM piece would be if you could buy more things from one supplier, then you'd actually be if you could find even another shipping thing from AliExpress or something like that, right, where you're saving by just shipping from the same supplier, you could start to save money too.
Yeah. And something I'm starting to do now is shipping directly to microfab. So what I used to do is shipping to my place and then pack everything together, ship it to microfab.
Hmm.
And now I'm just shipping directly to microfab and they stock things for me. And it does help. It's going to help me reduce cost because I don't have to manage the stock, but also it means that there's only one shipping here. And they have a great way to manage this where you say manage inbound shipments. And I should say that I'm not affiliated with Microfab. I don't get paid to say all of this,
Right,
but
right.
I declare all of my inbound shipments, what's coming in. And so when they get it, they're going to check it off as, yes, we've received those parts.
Oh, that's great. Yeah.
And they will go into my inventory here where I can see all the parts that are used in the project and how many I have in stock right now. So
Oh,
that's
okay. So it's like almost on-site. It's like on-site stock and like your own mini stock room.
yeah, exactly. And that's pretty nice. I get the benefit of feeling like I'm a big company, but
Hmm.
on my small side business.
Right,
But
right,
anyway,
right. No,
so the
this
other,
is good too because this is another thing where it's something that it feels like something you'd be doing with a normal assembly house, right? So
yeah, I'm guessing you have to do the same thing. And the fact that you manage it over HTML form and not Excel spreadsheet makes me very happy.
right, yep.
So then the other parts I buy online are the ESP8266. So that I just go on AliExpress. Now I have my favorite suppliers. I pay $245. And
Hmm.
one problem I had originally with China is that things would take a long time to get to me. But if you choose e-packet shipping, it's like a 2 weeks delay for shipping,
Okay.
which is really not that bad and working pretty well. The WS2812 RGB, they cost me 15 cents each. If you try to buy them on DigiKey, they're resold by Adafruit. And I love Adafruit, but I think they're $5 each or something, which
Right,
is
right.
really expensive for my purpose here. And then,
But this is actually another good point here. Sorry to cut in there. This is another
yeah,
good
no,
point that even the unit cost, right? So you're buying these things from AliExpress, but maybe it's not worth it to replace this kind of thing. I mean, it's 15 cents each, but maybe the cost of rework is actually higher than the cost of reducing that part off the board, right?
yeah. And yeah, that's something that I'll have to look at. But I can get back to the WS2812 because there's a lot of other considerations that
Mm-hmm.
come into this part that I can talk about more later
Got it.
on the global design. So then the KBox PCB manufacturing is the price that Microfab charges me for this board, and that's just for the PCB. So I could show what the project looks like. This is a finished board manufactured by Microfab, and so it's a 4-layer board, and you can see I've done some rework here. That's not
Yeah.
them when they send them to me. They're cleaner than that.
Hmm.
But this gives you an idea of the size of the board. I don't remember. I think it's 10 centimeters or 4 inches wide, something like that.
Hmm.
And so $50 per PCB for a 4-layer board in quantity of 10 seems a little pricey to me. I'm sure I could probably get a cheaper price for that. But the lesson here that I've learned is that the size of the PCB matters a lot in the cost of the total project, a lot more than I thought initially. And when I did my little bit back of the napkin calculation, I never took into consideration how much the PCB itself would cost. And plus, the shape that I have here fits perfectly into the box that I'm using.
Uh-huh.
But all that extra space here, that little corner, I'm getting charged for that because they're taking the rectangle in which the PCB fits.
Of course.
And
Right, because
so
that's on a
that's
panel
not,
and it's getting routed out, stuff like that, right?
yeah, exactly. And so that kind of stuff, just adds up and really means that next time I'm designing something, I'll be careful to actually reduce the size of the PCB because that is a very expensive part of my BOM right now. I mean, it's the PCB itself is the single most expensive item in there.
Wait, so can you explain this a little bit better? So PCB manufacturing, meaning that's the cost of just the PCB is $46?
Yes, exactly.
Oh, that's way too high. Why
Yeah,
don't can you consign a PCB to go to them or no?
I don't know,
Okay,
but
so
I
this is
can.
just part of their overall process. So this is
Yeah,
and this is very
I can
macrofab
ask them.
specific. That's fine. Um,
They've they've been super friendly and open, so
yeah.
I could definitely ask them.
Yeah. Okay, that's
Uh,
fine. Well, I mean, this is kind of the thing about a DFM process, right? So now you've paid for the prototype. You're fine with the costs. You're just trying to get something out there. Now it's about kind of taking a look at the lowest hanging fruit and understanding about each individual piece.
yeah, exactly. $51 is the total price of the PCB parts.
Hmm.
And so when you look at the project in microfab here, that's the individual cost of the part. That's the price that they pay to
Right.
buy the parts on my behalf from DGT or
Right.
Mauser.
Everything you're not consigning, right?
Yeah, exactly. And
Hmm.
then the other cost next to it is PCB assembly. And the way they do this is that for each part, they'll tell you what's the part cost and what's the labor.
Hmm.
And so you can see that this first part here, which is a SD card slot, cost $1.01 to buy, which
Hmm.
is already pretty expensive just for an SD card holder. I mean, you're seeing project from China that get sold for $5 that have an SD card
Of course.
holder in
Yeah.
them. So I'm clearly not buying the cheapest one here. And then they charge me another dollar to place it on the board. And I think that's a mix of a combination of the number of pins of the part mostly and also the size of the
Right,
part.
and all of the, I mean, like, so I think the other thing to, and I'm going to go back to our discussion here for a second. I think the thing to keep in mind here is that this is basically a prototyping tool, right? You would never keep doing this over time. Like if you were doing 100 to 1,000, you'd probably move away from a similar thing like this for now, right? You'd actually redesign it. You'd take it to a contract manufacturer, and as if you were trying to scale. And so it's really going to be a balance between how close to a prototype will this be or a super low run, right? For a super low run, it might make sense to keep going to them, and you just tell your customers, well, you're going to pay more because it's super niche kind of product.
Yeah,
So,
yeah,
um, so I think it's important to point out that this is very specific to your situation in macrofab, but it's not necessarily that you would move away or not move away. It's just that these are all the considerations you have when moving to the next stage of design and manufacturing.
yeah. And there are ways even with microfab to reduce the cost. So for example, all the resistors, I'm using what they're calling house parts,
Hmm.
on which they have no placement cost because I'm guessing they already have, reels of parts ready, calibrated, and so they just use those and they
Yes.
don't charge you any replacement parts
Right.
and they buy them by tens of thousands, so they're really cheap parts.
Right,
So
and that would be
as
another
much as
DFM piece where you could go back into your schematic. You could reassign certain components, right? So if you have an 0603 resistor that you've put in there, but then they have their own, you could go and put that back in, and that would lower your
yeah,
cost.
so that's a job I've already done for all the parts that they have in house parts
Hmm.
to get the price down, and this made a little bit of a difference,
That's good.
but
Okay.
not huge. Yeah.
Yeah. Okay.
Okay, so if I go back to go back to my Excel spreadsheet. So the PCB part, there's $51, $31 in placement and assembly, and then all the rest here are mechanical elements that are used in the assembly. And so that's a really cool thing that they do for me is that I tell them I consign all the part with them, and then I give them assembly instructions. And so I say, take the box that I've sent you, open it, and then save the screws, and then I ask them to drill holes. And so I've given them a
Hmm.
drilling guide, and they
Yeah.
have a PDF they can download.
Right.
And then I asked them to take the cover and remove the sticker and clean the box because the box is really cheap, but it comes with that sticker on top. And so they do all of this for me. Then
Right,
they
and this is
place,
something you would do no matter where you're going for manufacturing too, right? It's you would send assembly instructions. You might actually go and sit there and talk to them, but it's also something that any manufacturing process would have these assembly instructions. So this is really good stuff.
Yeah. And so, I've written all those instructions. And there's a fair amount of steps there to get to the end where they try to connect the USB cable. And, when you drill hole in the plastic, they don't always like go straight into the plastic. And so sometimes the connection doesn't work. And so I asked them to use a Dremel to make sure that they can actually plug a USB connector. They
Right,
put
right.
the
So
plug
this is
on.
another DFM piece too, like so maybe even moving that up so that the board meets the edge of the box, that kind of thing, right?
Yeah, maybe, yeah. And
Great.
so my point is that for all those steps, they're charging me $11, which I think is a bargain compared to the time it takes to do that manually on many boards.
Hmm.
And then you get to my total cost, which is approximately or pretty precisely $175 here for this batch of 10 KBox. The last batch, I was more at 190
Right.
for the entire process. So that's the overview of the cost.
Okay. That's a really good overview, and I think that all these things, so basically it's about. So obviously you talked about the assembly costs, you talked about the both mechanical and by humans, right, with the actual assembly, and so those are all considerations. I'm glad you included shipping. That's a huge piece too that a lot of people forget about. I think another thing that would be included if you were going straight from a factory like this to a user would also be packaging, right? So if you were user
Yeah,
packaging, user shipping, all that stuff. So yeah, the costs really add up, and I think that there's you could spend with this specific design you could try and optimize it a lot. Just the exact design as it is now. There's also the step where you can go and take the design and try and rejig some of it. Like I said, with moving the PCB up, making things more lowering handling time by making things a little simpler. All those things are potentially possible, but it's all about the trade-offs we talked about before
yeah,
in order to see if it's actually worth it.
yeah, absolutely. Yeah, so there's a lot of things I've been thinking about to reduce the cost, and I don't know if you want to get into that today or.
I think maybe in a future session we could talk about that, but we've been going for a little while here, so I think this is a good
Cool,
overview. And
cool.
but yeah, thank you for taking the time to talk to us today. Like I said, people can go and check out Thomas' talk. It's on this page here, which we will have linked. He gave a great overview of the technical details on how it works, stuff like that, and yeah, so I'm really excited that we've been able to talk about it. Thank you for being open with all of the information here. That's always really helpful too.
Yeah, no problem. Thank you, Chris.